Welcome to Gaia Edge by Code Zero. My name's Andy Ramgovin and I am the CEO and co-founder. Now, we've delivered this project on a Nano GB10 ZGX Spark from HP and NVIDIA, and we're going to be showing you our precision farming and agritech end-to-end platform using machine learning to drive innovation in agriculture. So we're going to whip through this really quickly, but we've done some decision tree modeling for classification and regression problems for things like yield prediction, where we're able to use publicly available data online to start predicting crop yields with things like machine learning, and then really understanding what are the main drivers, so things like nutrient intensity and rainfall. We then moved on to disease detection using ResNet CNNs for image detection and neural networks, where we're able to take, again, online data and to select a leaf, look at that leaf and detect whether that leaf is healthy or diseased. And you'll see now when we move into the next sprint, we took that one step further using a YOLO model, where we were able to do real object detection. So instead of doing single leaf classification, we're able to do multi-leaf detection, and again look at that image and detect whether that image is healthy or that image may be diseased. Now again, we're always at the beholden to the information we can find publicly available on sites like Kaggle, so we can do as much as we possibly can. And now we're looking at weather outlook and risk, as we know rainfall is quite a big indicator of crop yield. We've used a open Meteo API to bring in things like weather forecasting. Another really big area is soil pH. So using IoT sensors in the soil to measure things like NPK values, and then be able to predict what kind of NPK balance of soil pH is going to give you the best opportunity to get the best type of harvest with the ripest fruit. And that comes again into our harvest window. So taking, again, online publicly available data, where we can use, again, CNNs, things like ResNet, image detection and computer vision, where we can scan thousands of images of crops and work out whether they are ripe, overripe, ready to harvest, pre-harvest. And that kind of gives you a really good idea of what can be done in an end-to-end platform. Everything you're seeing now is built in Streamlit, and what you're looking at now is a technical appendix for every single sprint that we did where there was model training. And when we get to the TensorRT versus PyTorch, this was really important for us, because as you can see now, we've got some breakdown stats with inference per image. We have Grafana and Prometheus delivered on the platform. So we were able to actually really use NVIDIA's SDK and then be able to run it on NVIDIA Silicon and benchmark it against PyTorch. So the technical appendix is a really good way of us being able to show the data science behind it. And the final piece is Nexus, delivered by my business partner as a piece of software for Code Zero. I've changed the use case for this project around visualization of our machine learning pipelines, but also to include our sprint pipelines and all of our statistics.